definitely 190 mm will be the lesser value among the 3D and 300 mm, which is the spacing values. We have to consider the least value as earlier. So 190 mm will be the definitely least value. Therefore, provide 8 mm dia bars at the rate of 190 mm center to center in the middle strip of width 3.12 meter. Okay. So next step is reinforcement in H strip. So we know we have calculated earlier that AST minimum, area of steel minimum, is equals to 216 mm square. Now using 8 mm dia bars, the spacing will be 1000 into 50.3 by 216, that is equals to 232 mm. Now for spacing will be list of the following: 5D, 450 mm and 232 mm, which is calculated. So spacing should be 232 mm, or we can use 230 mm. Okay. So in each strip we calculated just like distribution bar of one way slab. AST minimum is enough reinforcement for each strip. Okay, so we took area of steel as AST minimum, and spacing consideration is also like distribution bar of one way slab. That's why the spacing amount will be list of these followings, slightly different than the main reinforcement. Okay, so now using 8 mm dia bars at the rate of 230 mm center to center in the H strip of width half into 5.16 minus 3.9, that is equals to 1.04 meter along x direction, and H strip of width half into 4.16 minus 3.12, that is equals to 0.52 meter along y direction. In this case we use half because from the full effective span, if we deduct middle strip, we will get total length of H strip from both sides. But here we have to for reinforcement, providing reinforcement and design, we have to know the one side of H strip. That's why we have just multiply the half value with this to get one direction, only H strip, one H strip. Okay, now next step is check for shear. Is in common format. Nominal shear stress tau V is equals to VU by BD. Shear we have calculated earlier. So VU is 36,770 by 1000 into 153, that is equals to 0.24 Newton per mm square. Percentage of steel AST by BD into 100, we know this formula. So AST is 335 by B is 1000 and D is 161 into 100, that is equals to 0.21%. Now for percentage of steel 0.21% and M20 grade concrete, we have to find out the value of tau C from table number 19 of IS 456 2000. So let's check the table number 19. So table number 19, design shear strength of concrete, tau C in unit is Newton per mm square. So now in left column 100 AST by BD, percentage of steel, 0.21 is not in the list, but 0.21 is lies between 0.15 and 0.25. Now for M20 grade of concrete, percentage of steel, if 0.15, then the tau C value is 0.28, and for 0.25 the value is 0.36. That means for 0.21 it definitely lies between this 0.28 and 0.36. We have to interpolate that. So now we have to interpolate. Now tau c is equals to 0.28 plus 0.36 minus 0.28 over 0.25 minus 0.15 multiplied by, within bracket, 0.21 minus 0.15. The value will be 0.33. So the tau c value is 0.33. Now for 180 mm thickness of slab, value of K coefficient is 1.24, which you can find out from clause number 40.2.1.1 of IS 456-2000, page number 72. I have already showed in last video for one-way slab that page. Clause number is written here, you can easily find out there. So K value is 1.24. So K tau c is equals to 0.33 into 1.2, that is equals to 0.41, which is greater than tau v. That means no shear reinforcement is required because there are no excess shear. Okay. Now next step is check for deflection. So for this, first of all, we have to find out modification factor from IS 456-2000 figure 4. That modification factor will be multiplied with length to depth ratio, right? So percentage of steel is 0.21, we know. Now Fs, this formula is given just below figure 4 of IS 456-2000, 0.58 into Fy. AST required by AST provided, that is equals to 0.58 into Fy is 415, within bracket AST required is 333 by provided is 349, that is equals to 240 Newton per mm square. So we have to find out modification factor for percentage of steel 0.21 and Fs 240 MPa. So let's check figure 4 of IS 456-2000. So this is figure 4 of IS 456-2000. Fs is 240 and percentage of steel is 0.21. So from this two we may find out the approximate value of modification factor. So modification factor is almost 1.6. For simply supported beam, LYD max is equals to 20 into modification factor 1.6, that is equals to 32, and length to depth ratio provided, LYD provided, is equals to 4161 by 161, that is equals to 26. So this value is lesser than the maximum value, hence it is okay. So next step is torsional reinforcement at corners. In case of two-way slab, in every corner, torsional reinforcement or corner reinforcement have to provide to resist torsional moment which comes in two-way slab. So as per IS code consideration, mesh size is Lx by 5, that is equals to 4.16 by 5, that is equals to 0.832 meter, which is equivalent to 840 mm. Now area of torsional reinforcement is 3/4, that means 3 by 4 of 332.5, that is equals to 250 mm square. Now using 8 mm dia bars, dia of one bar we know 50.3, so spacing is 50.3 by 250 into 1000, that is equals to 201 mm, or you can say 200 mm. So provide 8 mm mesh of bars at 200 mm center to center in a mesh. Now design part and reinforcement part is complete. Now time to arrange reinforcement, okay, before the drawing. So before starting this arrangement consideration, just check out once the IS code provision about this arrangement. Now look, as per IS code provision, Annex D of IS 456 2000, clause number D 1.4, tension reinforcement provided at midspan in the middle strip shall exceed in the lower part of the slab to within 0.25 L of a continuous edge or 0.15 L of a discontinuous edge. So depend upon this edge condition. Now, as per code provision, the reinforcement arrangement. First, on the bending half of the main bars at a distance 0.15 Lx, that is equals to 0.65 meter from the center of support, or 650 minus 150, that is 500 mm from edge of support along x direction. Available length of bars at top 650 minus 130, that is equals to 520 mm from center of support. Now next part is bending half the main bars at a distance 0.15 ly, that is 775 mm from center of support, or 775 minus 150, that is 625 mm from edge of support along y direction. Available length of bars at top 775 minus 130, that is equals to 645 mm from center of support. So regarding this reinforcement arrangement, we have to draw the figures. So this is a longitudinal section of short span. So you may see here the drawing. From drawing you can understand the overall length, the effective length, everything, and the distance of bent up bar. Okay, everything is written in drawing. Now next drawing is along long span. The span length change as per our question and as per our calculation. So these are the length and distance of bent up bar, lower portion and upper portion. Okay, so this is the drawing. Next part is plan of bottom reinforcement. Okay, so here everything is given: middle strip, edge strip and corner reinforcement. This is the main plan of bottom reinforcement, which we have mainly designed, which you have get through the design. As per the design, this drawing has been done. You can see here the mesh size, edge strip size, number of dia of bar at given support. So this is another view which is of top reinforcement. Here edge strip and mesh are given, but middle strip is not given. And this is the main drawing. So here the problem is end. Thank you.